All right, what's up, guys? In this video, I'm going to pick up some multivariable calculus, and we're going to be talking about curvature in this video. So we're asked to consider the circle given by r of t is equal to r cosine of t, comma r sine of t, for t is between 0 and 2 pi, where r is greater than 0. They want us to show that k of t is equal to 1 over r. So there are a variety of formulas for the curvature, far too many, quite frankly. So I'm going to write it down for you what we're going to use. All right, so remember for the curvature, and again, there's a whole bunch of formulas for the curvature. So for the curvature, it's going to be 1 over the magnitude of v of t, or the magnitude of v, multiplied by the magnitude of dt over dt, where t, the uppercase t, is the unit tangent vector. And that's going to be equal to the magnitude of the first derivative of the unit tangent vector divided by the first derivative of r of t. So this is what the formula is in our case for the curvature. Okay, so a couple things to keep in mind, and this is where my physics background will kick in. So remember that the v here is the velocity. Now let's think about this in terms of physics. So remember that the velocity, if you took physics in high school, you were always taught that the velocity was delta x over delta t, where delta is the triangle, and that means change. So it would be the change in x, which would be the position, over the change in time. That's what you learned in high school physics. But in terms of if you want to give a calculus definition of the velocity, then it would be the first derivative of the position, let's say, of some particle with respect to time. So the velocity would just be the derivative of the position. We'll just call the position x. It can be called r in some cases, but we'll just say x with respect to time. In other words, it's the first derivative with respect to t. If we look here what we're given for r of t, keep in mind that v of t is the same thing as r prime of t. Because to get the velocity, I take the first derivative with respect to t. So v of t is the same thing as r prime of t. It's the first derivative. Even though they aren't asking us for acceleration in this case, acceleration would just be the derivative of the velocity with respect to time. Other words, it would be the second derivative with respect to t, if that's what we were given, as it pertains to variables, that is. So let me just remind you of what a lot of this stuff means again. So remember r of t, that's just a smooth parameterized curve. So it's just a smooth parameterized curve. Remember, v of t, that's equal to the first derivative of r of t. So it's equal to r prime of t. And again, it's just a velocity. That's what the v stands for. And then the t that you see, the uppercase t, that's the unit tangent vector. Okay. So the first thing that we need to go ahead and do is to take the first derivative, essentially. So essentially, we need to find r prime of t. R prime of t is the same thing as v of t. So that's what we're going to look for first. And then we'll take the magnitude of v of t, or the magnitude of r prime of t, basically. And we'll see what that gives us. So let's go ahead and take the first derivative. So we'll have r of t is equal to, and we'll take the first derivative. So we'll look up here at our r of t, and we'll take the derivative. So this would be minus r sine of t, and then it'll be r cosine of t. So we basically differentiate each piece of our vector function. Okay, so now let's find the magnitude. So we need the magnitude of v of t. Again, that's the same thing as the magnitude of r prime of t. So remember, the magnitude, that's just the square root of the sum of the components squared. So we'll set up our square root here, and we'll take what we have. So that's going to be minus r sine of t. We're squaring that. And we'll add that to our cosine of t, which we're also squaring. And let's go ahead and kind of square everything and kind of simplify everything out. So I'm going to factor out an r squared. So we'll get r squared. And then on the inside, I'll have sine squared of t plus cosine squared of t is in there. Now remember that sine squared of t plus cosine squared of t, that's just 1. So we're essentially multiplying r squared by 1, which is just r squared. Taking the square root of r squared gives us r. So therefore, we can basically say that the magnitude of v of t, which is equivalent to the magnitude of r prime of t, is simply going to be equal to r in this case, if we go through and actually do the work. So we now have one piece of the puzzle taken care of. That's the first piece. We're not done, obviously, but I'm just circling the first piece of the puzzle, which we've taken care of. Okay, now what about that unit tangent vector? So the unit tangent vector, that's that uppercase T that you saw up there in the formula. And I've done videos on the unit tangent vector before. So the unit tangent vector, that's just r, the first derivative of r of t, all divided by the magnitude of the first derivative of r, which is r prime of t. So it's going to be r prime of t all divided by the magnitude of r prime of t. Okay. So if we use that formula for the unit tangent vector, which I'll get another sheet for, we can actually go through and do this. So we got our formula for the unit tangent vector. It's going to be r prime of t all divided by the magnitude of r prime of t. So what we'll have is basically our first derivative. Remember that was minus r sine of t comma r cosine of t. And then we divide all of that by the magnitude of r prime of t. Remember that was equivalent to v of t, which we know was r. So in this case, we would just divide all of this by r. Okay, so that's what we would divide it by. And we clean it up a little bit here. So if we wanted to clean it up, well, actually, I tell you what, I'm actually going to wait to clean this up a little bit because I want to show you. Well, no, I changed my mind. Actually, I changed my mind. I'll go ahead and do it here. I want to show you something else. But so if we go ahead and simplify this, well, the r's, they just go. The r's cancel here. R cancels there. We still got the minus. So that's minus sine of t comma positive cosine of t. Sorry, it's a little hard to see. That's what it's going to be. So I was going to wait till I showed you that, but actually, I just went ahead and did it. So what that means is that dt over dt will simply be equal to negative cosine of t, comma, minus sine of t, because we would take the derivative of the unit tangent vector, okay? Because remember, when we go back to what we had at the beginning here, we had our formula for the derivative of the, or not the derivative, we have a formula for the unit tangent vector, which is first derivative of r of t, all divided by the magnitude of r of t, or r prime of t, excuse me. So r prime of t divided by the magnitude of r prime of t, which is equivalent to v, which is the velocity. Okay, so now we use the formula. So remember what the formula was. The formula was k of t is equal to 1 over the magnitude of v, and that was equal to the magnitude of dt over dt, which is the derivative of that unit tangent vector. And that was equal to the magnitude, again, of our unit tangent vector, the first derivative of our unit tangent vector, all divided by basically r prime of t. So we just got to plug the information in and see where we go from there. So looks like we'll have k of t is going to be equal to 1 over r, and then it'll be the magnitude of negative cosine of t comma minus sine of t. So, and what that's going to give us is 1 over r. And same thing, we'll take the square root of all that. So the square root of the sum of the components squared. So that'll be negative cosine of t squared plus minus sine of t squared. We know since we're squaring these, they become positive. So this essentially becomes the square root of cosine squared of t plus sine squared of t. Again, hopefully you remember from trigonometry that cosine squared of t plus sine squared of t is equal to 1. So this is essentially the square root of 1, which we know is just 1. So in this case, what we actually have now is 1 over r. And again, this is essentially what we had. Square root of cosine squared of t plus sine squared of t, which we know is 1. And what is that going to give us? Well, that's just going to give us 1 over r multiplied by 1. Well, 1 over r multiplied by 1 is just 1 over r. So we'll essentially just end up getting 1 over r. So essentially what we've done is we've proven that what we were given at the beginning, which was, or what we were asked to prove, we were asked to prove that k of t was equal to 1 over r. Well, basically that's what we just did here by doing all this work. So we're asked to show that k of t is equal to 1 over r. When we got down here to the bottom page, we basically did that. K of t is in fact equal to 1 over r. And we just used the following formula here for that. So that would actually be the answer. So for the final answer on this sheet, I'll just essentially say that we have proven that k of t is in fact equal to 1 over r. So for the most part, if you're good with things like finding the magnitude of a smooth parameterized curve, or if you're given some vector function, vector valued function, where you take your derivatives of the first, second, or in some cases third components of the vector function, and you basically just have to follow the formula. And a lot of this, like I said, isn't very hard to understand at all. It's just pretty straightforward. But it does take a little bit of intuition and, just make sure you know how to take derivatives and all that good stuff. And you just have to follow basically the process, go through and show how you did it. So that's the answer. So you'll start getting into this stuff in Calc 3. Calc 3 is actually, to me, Calc 3 actually was easier than Calc 2 and Calc 1 for some reason, because we live in a three-dimensional world. So three-dimensional calculus is not that bad. I actually like Calc 3. All right, so that's your answer. So if you got any questions about it, let me know. But other than that, I will see y'all next time. Thanks for joining.